Right, these are our notes for 5.10d, solving radical equations. We are going to start with this example problem. Square root of 30 minus x, that's the radicand on the inside. Outside we have minus x equals 0. Our first step is to isolate the radical term, meaning get it by itself. So my radical term is just the square root part. Outside it has a minus x. So to isolate the radical, I need to move this negative x over to the other side by adding or doing the opposite. So then I have the square root of 30 minus x equals x. So I have done step 1, isolate the radical term. Step 2 is to square both sides. That's going to get rid of my square root. So whatever you do to one side, you have to do to the other. So square cancels out square root, leaving me 30 minus x equals x squared. The next step is to solve by factoring, and these bullets here are the individual steps to do step 3. So the first thing, and here's your first clue that you have to solve by factoring, is because we have a quadratic term here. So we want to get the equation equal to 0. And I always start that process by finding my quadratic term. It's right here, x squared. If it's already positive, I'm going to leave it there and take this stuff from the opposite side and move it over. If it was negative, I would do the opposite of that and move it to the other side. But it's positive, so it's going to stay right here. So these things on the left, I'm going to do the opposite of to move them to the right. So everything on the left cancels out, leaving me 0. And then on the right, I have x squared minus 30 plus x. Now, I am going to use standard form to rewrite those, meaning the ax squared plus bx plus c. That will help me in my next step when it's time to factor and I have to figure out my a, b, and c. So x squared plus x minus 30. So that's get my equation equal to 0. So now I need to factor. This is going to be the cross method, what multiplies to AC and adds to B. So my A is 1, my B is also 1, and C is negative 30. So A times C is negative 30, and B is positive 1. And what multiplies to negative 30 and adds to positive 1 is 6 and negative 5. And because A is 1, I can do the shortcut cross method where I do not have to split the middle term and do grouping. So I'm just going to go straight to factored form, x plus 6 times x minus 5. Now, anytime you have two things being multiplied to 0, it has to be true that one or both of them equals 0. So we are going to set each of those equal to 0 and solve them. So x equals negative 6 and x equals 5. Now, a lot of times in math, when we have this check step at the very end, it's kind of optional. It's just if you want to check your work, it's there and it's good to do. But today you have to check, because anytime you introduce a positive exponent, you square both sides or you raise both sides to the 4th power or the 6th power, what happens is you might introduce what's called an extraneous solution into your situation, meaning you get a solution that doesn't actually work. So we are going to check both of these. So I'm going to start with x equals negative 6. I'm going to plug it into my original equation wherever I see an x. So 30, this minus comes from the equation. This one comes from my solution that I'm checking. So 30 minus negative 6, that becomes a plus in here. And then this minus comes from the equation, and this minus comes from plugging negative 6 into that x. And I have another plus situation here. So I have square root of 36 plus 6 equals 0. Square root of 36 is 6. and it is not true that 6 plus 6 equals 0. So that solution does not check out. So let's check x equals 5. So I plugged 5 in for the x's. In the radical, I have now 25, and the square root of 25 is 5, and it is true that 5 minus 5 is equal to 0. So I have one solution to this equation. Now, for the rest of the problems, there's 2 of each type, so I'm going to work one and ask you to pause and try the second one. So we're going to start that right here with this first row. So in this particular example, the radical is already isolated, so we don't have to do step 1. So we're going to go straight to step 2, squaring both sides. So y squared equals 7y minus 10. Now solve by factoring, which means to start by getting the equation equal to 0. Here's my squared term, it's already positive, so I'm going to leave it on the left and move the things on the right over there by doing the opposite of them. So negative 7y and positive 10, or plus 10 to both sides. So on the right, everything cancels, and on the left in standard form, I have y squared minus 7y plus 10. This is short method because a is 1. So what multiplies to 10 and adds to negative 7? And that's negative 5, negative 2. So my factored form looks like this. Y minus 5, y minus 2 equals 0. Set these individual factors equal to 0. That's an equal sign, that's 0, just to save some time. And then just add 5 to both sides here, and I'd get 5. Add 2 to both sides here and get 2. Now, when you're actually checking, I don't necessarily need you to show me this kind of detail work for checking. Just plug it in, do your math real quick, even do it mentally, as long as I can tell you've done the process. So if I'm checking 5, I'm going to put it in for the y, and then here 7 times 5 would give me 35. So 35 minus 10, that is 25. Is it true? True statement? Yes, that is true. Plugging in 2 gives me 14 minus 10 in the radical, which is 4. And is that statement true? Yes. So this has 2 solutions. So you pause the video and try number 2 on your own. All right. So hopefully you started by squaring both sides. Again, my quadratic term is positive on the left, so I'm moving the stuff from the right over there by doing the opposite of each of them. So I'm going to write it in standard form, so that's going to be x squared plus 2x minus 15. So what multiplies to negative 15 and adds to 2, that is 5 and negative 3. So here are my factors. Set them equal to 0. You solve by doing the opposite, so that's negative 5 and positive 3. And I'm going to check those by putting them into the equation. So negative 5 equals the square root of 15 minus 2 times negative 5. Now I have a couple of things to say here. One, you're never going to, in this situation, square root a number so that it equals a negative 5. So right there, I already know this solution doesn't work. But I also want to just talk about the math inside the radical. You have to follow your order of operations here and do multiplication before addition and subtraction. So this multiplication is a negative 2 times a negative 5. That's going to be a plus plus situation. So 15 plus 10 is 25. So square root of 25 is positive 5, does not equal negative 5. So that one doesn't check out. And then plugging the 3 in to the original equation, 2 times 3 is 6. So is it true that 3 equals square root of 9? Yes. So I only have one solution here. On these bottom problems, the variable, or I should say the radical term, is already isolated, so I'm just going to square it. I am going to need to factor and get it set equal to 0, so that means minus 8x to both sides. Now, in this situation, I don't have a trinomial, so I'm not going to do cross method. What I'm going to do instead is a GCF. They both have an x, so I'm going to divide it out. And now this is my factored form. And I still am going to break them up and set them equal to 0 and solve them. So I have x equals 0, x equals 8, plugging them in to check. That one checks out. Plugging in 8 to check. 8 equals square root of 64. Checks out. So that is 2 solutions. Please pause your video and try number 4 on your own. All right, so I'm going to do that one a little bit faster since it's just like number 3. 10m equals m squared. Subtract 10m to both sides. M squared minus 10m. Take a GCF of m out. Set those both equal to 0. So m equals 0 and m equals 10. And both of those check out. I think I'm going to make a second video for this part.